and today we are going to study a scatter plot. So let's know what the meaning of a scatter plot. A scatter plot or a scatter diagram is two-dimensional graph in which the point corresponding to two related factors are graphed and observed for correlation. What the meaning of the word association or correlation? What the meaning of the word association? We can hear this. What the meaning of the word association?
Relations.
Relationship, yes. Okay. A downward trend in points shows a negative correlation, and upward trend in points show a positive correlation. If there is no trend in graph points, then there is no correlation. So we divided the correlation into three parts, which is we divided the correlations into three parts, which is positive
Positive
correlation,
correlation.
negative correlation, and no correlations, right? Again, we can divide the correlation into three parts, which is
Positive correlation.
positive correlation. And when we will know that this one is positive and this one is negative, we said a downward trend in points shows a negative correlation. An upward trend in point shows a positive correlation. If there is no trend in graph points, then there is no correlations. The following diagram shows some examples of a scatter plots and correlations. Here is it. We can see in front of us now in this diagram that we have positive correlations. But sometimes we have a strong positive correlation and we have weak positive correlation. If there anyone can tell me what is the difference between those two types? What is the difference between a strong positive correlation and weak positive correlation? Judy?
The strong positive when the points are close to each other.
Yes, when the points are close to each other, exactly. The space between the points are very small, right? And the opposite. What is the weak positive correlation? What is the weak positive correlation? Hannah?
The weak positive correlation is when they're not close to each other, so you wouldn't tell if they're positive because some people would think it's no correlation, but it's going in the positive way
Yes,
direction.
yes. So we can note here in front of us, we can note the two examples here at the top, right? So we have the first one, all the points is upward, right? And here also the points is upward. As Hannah said, someone can say that this is no correlation. No, because all of them, they are moving upward, did you see? But there is a space between the points. In this case, we can't say that it's no correlation. We will say that it's a positive correlation, but it's weak correlations, okay? But this one, we can note that the points, it's very close to each other. So this is called a strong positive correlations. The example here represent no correlations. Why? If there anyone can tell me why we can say that the second example represent no correlation? Why this one it will be no correlation? Yes, Johanna.
Because it's not going a certain side.
Because it's not going
Going a
certain side.
certain
Yes, it's
way.
not upward or it's not downward, right? It's in everywhere. So if it's in everywhere, so this one represent no correlation. And the same we are going to say about the last two examples. A strong negative correlation. Kinsey, could you please explain to me the two examples down? What are the two examples down related to?
Is a negative correlation?
Yes.
The strong that have a line that should be follow the line, and the weak the weak negative
Upward or
correlation.
downward? The data move upward or downward?
Downward.
Downward, yes, downward. And we have how many types as you see in front of you?
Two.
Two types, yes. The first one is
Strong negative correlation,
strong negative
and the
correlation.
second is weak negative correlation.
Thank you so much. Thank you. So, who can tell me a summary about the types of correlation, which we talk about it till now? Who can tell me a summary? How many types of correlation we can find while we are studying scatter plot? Yes, Reem.
Okay, we have three types of correlation:
Yes, we have three.
positive, negative, and no correlation.
Yes, positive and negative and no correlation. It depends on what, Yareem?
The way the points are moving.
The
If
way.
it's increasing, it's positive. It's decreasing, it's negative.
Thank you. So if it's upward, so it will be a positive correlation. If it's downward, so the negative correlation. If there is no way and it's random for everywhere, so this would represent no correlation. Thank you. Now we want to know the scatter plot. How many data we can find with the scatter plot? We will learn that a scatter plot is a graph in which the data is plotted as points on the coordinate grid. And note that a best fit line can be drawn to determine the trend in the data. If the x values increase as the y values increase, so the scatter plot represents a positive correlation. If the x values increase and the y values decrease, so the scatter plot represents a negative correlation. If the data is spread out so that it's not possible to draw a best line fit, there is no correlation. So let's watch an example and then we will back to explain again.
The data is plotted on a coordinate grid. So the horizontal axis will be the x-axis, and the vertical axis will be the y-axis. To draw a scatter plot for the data shown here, notice that the table shows the number of traffic tickets that Judy received each year for a 10-year period. So begin by titling your scatter plot, Judy's traffic tickets. Next, draw the axes for the scatter plot. The x-axis will be labeled with years, and the y-axis will be labeled traffic tickets. We know that the years listed along the x-axis will be the same as those listed in the table: 80, 81, 82, 83, 84, 85, 86, 87, 88, and 89. Along the y-axis, we need a scale. I would suggest using a scale starting with 0 with intervals of 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we simply plot the points. In 1980, Judy received 9 traffic tickets. In 1981, Judy received 8 tickets. In 1982, Judy received 7 tickets. In 1983, Judy received 5 tickets. In 1984, Judy received 5 tickets. And in 1985, Judy received 5 tickets. In 1986, Judy received 4 tickets. In 1987, Judy received 1 ticket. In 1988, Judy received 3 tickets. And in 1989, Judy received 2 tickets.
What kind of correlation there is in this data? What kind of correlation is there in this set of data? In your opinion, grade 8?
Negative.
Negative correlation. From where you know?
It's going downwards.
It's going downwards. Very good. It's going downwards. Thank you. And now we want to know how we can draw the trend line.
Notice that there seems to be a best fit line. Draw a line that matches the points. This line will be the best fit line. In the scatter plot, notice that as the years get bigger, the number of tickets gets smaller. Since as the X values increase, the Y values decrease, we say that there's a negative correlation.
Present the scatter plot. Tell me the main 3 points which you are going to do it. The main 3 steps, grade 8. How we can draw or create a scatter plot. How? What are the main 3 points to create a scatter plot? You have a set of data, right? And you want to draw it graphically. So what are the 3 main steps you have to do it? We will draw what first?
Plot the points.
We have to choose the scale, right? So the scale, it depends on the data which we have it in the table. So he will give us a set of data for X values and Y axis and Y values. And next we have to create a scatter plot. So let's watch this example.
So you've collected some data, and now you want to show it off to the public so that they can understand the results of what it was you were doing. Well, what better way to do that than by creating what's called a scatter plot? That's what we're going to do in this clip. I'll show you how to make a scatter plot on the left with an example, and then at the end of the clip, I'll get you to try your own problem, and you can make a scatter plot yourself. So let's have a look at the first problem that I'm going to solve. The stopping distance of a car has been recorded below. And in A, create a scatter plot. And then in B, we're going to look at the scatter plot and ask ourselves, is there a trend? Do we see anything? And we've been given the results of the study in a table that looks like this, where the first row is the speed of the car, and the second row is the stopping distance in meters. So we have a bunch of points, basically, or ordered pairs that go together. So we need to put those on a scatter plot first in A.
So the relation here in this data, it's between what, grade 8? The relation here is between speed of
car,
yes, and
stopping distance.
then the stopping distance. Thank you, Judy. Then speed of car and the stopping distance. Do you notice anything about the speed of car? Look at the data for the speed of car. It's what? It's a 25, 35, 45.
It's increasing.
It's increasing. Thank you, Kinsey. It's increasing. And the stopping distance, it was 10, 15, 21, 27, 33. What do you notice?
Positive correlation.
It will be positive correlations. From where you take your decision? You take your decision according to what, Kinsey?
According to the stopping distance.
And according to the data for both variables, right?
Yes.
You note that? Usama.
Yes, yes.
Good morning. What do you notice about the two set of data, ya Usama? Set of speed of car and stopping distance. What do you
They're both increasing, so it will be positive correlation.
Thank you. They're both increasing. So this one, it will represent a positive correlation. Thank you. Let's continue.
Let's get started. Like most graphs, a scatter plot requires that we make an X and a Y axis. So let's make those first. Here's our X-axis, and it has an arrow on the end to show that it continues on. And we have a Y-axis that goes up, and it has an arrow also to show it continues on. The first row, the speed of the car, that will be our X-axis down the bottom. Now, we need to figure out how many intervals to make on the X-axis. Well, if you look at these numbers, it looks like they range anywhere from 20 up to 110, and they seem to go up roughly 10-ish every time. So I'm going to divide the X-axis up into 10 sections. And I'm going to do my best to try and make each section equal. So there's my first dash. I'll have a second dash there, a third dash there, 4th, and then we'll just continue that trend. There's my dash marks. Now I can start numbering them from 10 all the way up to 110. And they go up by 10 each time. So there's 20, there's 30, and so on. There we go. Final thing I need to do for the x-axis is to let the reader know what I'm showing here on the x-axis. Well, it's the speed of the car in kilometers per hour. So let's just add a title to the axis. Speed. And always put your units. I'm going to put kilometers per hour. And our x-axis is now done. So let's do the same now for the y-axis. It's going to be the stopping distance. How many intervals should we have there? Well, it looks like roughly the same. We can go up by 10 pretty safely and fill in all the values. So let's do that. We'll have 10 dash marks, just like on the y or the x-axis, that are spaced out nice and even. So there's 3, and I'll just continue that. And now we can start numbering the dashes, just like on the x-axis. So the first one's 10, then 20, yep, then 30, and then we'll just complete the rest. There we go, from 10 to 110. Now we need a title for the y-axis, and it's the stopping distance in meters. And since I'm running out of room, I'll just put SD for stopping distance, and my units, of course, are meters. There we go. Now comes the fun part. We start actually plotting our points on the scatter plot. So the very first point has an x value of 25 and a y value of 10. Let's go back to the graph and we'll find 25 right about here on the x-axis, or the speed, and the stopping distance is 10. So I go up until I've reached 10 on the y-axis, and I draw my first point like that. Then I'm going to do the next point. It has an x value of 35 and a y value of 15. 35 is right here, and I go up to 15, which is right in between that 10 and 20, and there's my second point. The third one will be 45 and 21. 45 is right about here, and 21, say roughly right there. So now in B, we're asked, is there a trend? Let's have a look at the dots. You can see right off the bat, there is definitely some kind of trend. The line is going uphill, so it's a positive slope. We can show that with an arrow, just like this. If I draw this arrow, and I try and match the dots as best I can, it's probably going to look something like that. So we're definitely going uphill. But you'll notice it's not perfectly linear. When I try to draw a line, I couldn't connect all the dots. You see?
Could you please tell me the last point? When we try to connect all the points in one line, we can? Yes, Johanna. We can connect the points in one line?
No, because it was curved.
Yes. We can't connect, we can't draw a line. It will pass through all the points which we have it in this set of data, because it's not linear, right? For this reason, we have to draw a line. This line, we can call it the line of best fit, which is can be passed through some of points, but will not pass through all the points. So again, because this data is not a linear, it doesn't have the same slope between each 2 points. For this reason, we are going to learn scatter plots and best fit lines. Okay?
There's a curve to all of our dots. So it's not exactly linear. And that's because the faster your car is going, the longer it takes to stop. So we have a positive trend that is non-linear. And there's how we make a scatter plot. Let's get you to practice your own scatter plot now with your example. The attendance at a school hockey game has been recorded below. A, create a scatter plot, and B, is there a trend? And here is your table of values. You can see we've got the games in the first row and the attending.
This is another example. The attending at the school hockey game and being recorded below. The game 1, 2, 3, 4 till 8. and the attendance 125, 111, 122, 105, 193, 85, 72. Is there anyone can tell me this relation, it will be, do you expect to be positive correlation or negative correlation? Yes, Yusuf.
Negative. Oh, sorry.
Negative correlation.
Negative correlation, agree with that?
Yes,
Yusuf,
of course.
of course. Okay, so we will check the answer together. We are going to draw the scale then, and then we will say that yes, yeah, Yusuf, it was a negative correlation. So let's continue.
All right, here's our scatter plot for the hockey attendance at this school. We can see that there is some sort of a trend. It looks like attendance has been dropping off. I guess the team is on a real bad losing streak, and less people seem to be going to each game, except for game 3. Maybe it was a really good matchup. Game 3 had more people than game 2. But if you eliminated game 3 and just didn't pay attention to that dot, it's a definite, strong negative trend going downwards. So to answer B, yes, there is a trend, and it's negative. Keep in mind we had a title, games on the x-axis, attendance is on the y-axis, and we had a main title, and the interval for games was just 1, and we chose an interval of 20 for attendance.
This is John Zimmerman with tabletclass.com, here to give you a little bit of information or guidance, if you will, on scatter plots. Okay, so generally taught, I don't know, let's say 6th grade, 7th, 8th grade, around there. It's also, you also may know this as like the best fitting line. Okay, so best fitting line, scatter plot, this is what I'm talking about. So I'm just going to go over a quick example, just to kind of hopefully illustrate the main concept behind the scatter plot and some of the terminology that goes along with it, and hopefully you find this of value if you're studying scatter plots. Okay, so here I have a kind of like an XY axis set up, okay, and on my x-axis I have age, right, and my y-axis I have height. And what I'm doing is I'm just kind of, let's suppose I'm just collecting information kind of on, let's say, 100 different people, okay, starting from, infants all the way up to teenagers. And what I'm doing is getting their age, and I'm correlating it with their height, and let's say inches, okay? So, for most people, as you get older, you're going to be growing. Okay, some of you might, know counter examples. Somebody, is just can't grow no matter what, and they have this huge, growth spurt. But nevertheless, generally speaking, in our human beings, as you get older up to a certain age, you're going to be taller, right? So what we want to do is we like to use graphs, if you will, to be able to plot this kind of data, okay? And what we're looking for is trends, okay? So scatter plots, the whole value, the whole idea behind scatter plots is to be able to plot data and kind of look for correlations, and that's one of these words that we use in scatter plots. So let's go ahead and just make up some quick examples. So let's say we know somebody who's 1 years old, 20 inches. Okay, they're 20 inches. Let's see, a 5-year-old person, maybe, I don't know, like say 40 inches. 10-year-old, maybe they measured in here like around 59 inches. 12 years old, maybe they're a little bit taller. Okay, somewhere, I don't know, say 70 inches. That's pretty tall. But let's say that was the case. Okay, actually 70 inches. That's pretty. Yeah, I guess that's a little bit taller than average. But nevertheless, you can see what's going on here is as we plot these points, we can see a trend. Okay, the trend is that as we get older, okay, we get taller, right? And that's the whole idea, is to be able to take a bunch of numbers and to be able to plot them and see what's going on, right? So that's the whole idea behind scatter plot. Now, there is something else called the best fitting line, and what that means is, as you plot a bunch of pieces of information, let's suppose in this manner, okay, and your data look like this, okay, what you want to do is to find the best fitting line. This is just kind of like an eyeball thing. It's like, okay, if I was to draw a line, one line that kind of generally represented what's going on here, maybe my line would be like this right here, right? Okay, that would be like my best fitting line. Now you might have drawn your line a little bit differently, but it doesn't make a difference. I think you kind of get the point what I'm trying to do. Now, what you're asked to do in especially in algebra classes is to find the best fitting line. So let's say you're in 6th grade and all you've studied is just the basic idea behind scatter plots. This might not pertain to your math course, but let's say you're in algebra 1, algebra 2, whatever. You might be able to be asked to find an actual equation to represent what's going on here. So that would be like in y equals mx plus b form. So you'd have to take two of these points here. Okay, pick 2 points that best represent what's going on. Okay.
So we found already the line of best fit, right? And we said that to draw a line of best fit, you will try to find a line, connect between points, and divide a whole set of data into 2 parts. A point above the line and points under the line. Next part, we want to form an equation about the line of the scatter plot. Did you remember? What is the general form for the equation? What is the general form for the equation grade 8? Should be what? Y equal
Y equal mx plus b.
plus b. And what's m donate for?
Slope.
Slope. And what's b donate for?
Y-intercept.
Y-intercept. Yes. So we will choose 2 points out of the line of best fit or belong to the line of best fit. If you want to write the equation of this set of data. So we are going to choose 2 points belong to the line of best fit. The meeting, it will be end, and we will meet in the second part.